Hello, I'm Giulia Leghissa from the editorial board of Build Up Portal. Today we are hosting our third expert talk on Build Up. Due to the current circumstances of COVID-19, this interview is being done remotely. It is a pleasure to introduce you to today's expert, Laura Maturi, a senior researcher at EURAC Research. Welcome.
Thank you very much, Giulia.
So I just give a brief presentation and background of Laura. She's an engineer, an architect, and has a PhD in environmental engineering from University of Trento. She is currently senior researcher at the Institute for Renewable Energy at EURAC Research and has been working for over 10 years in the renewable energy sector, focusing on BIPV, building integrated photovoltaics, photovoltaic systems, and energy efficiency in buildings. Laura has participated in many national and international projects dealing with these topics. Some of them are Interreg, BIPV Meets History, H2020 PV Impact, International Energy Agency PVPS Task 15, etc. She will explain later all of them. Since 2017, she is the coordinator of the EU-funded project H2020 Energy Matching, which aims to develop novel technologies for the retrofitting of residential buildings by maximizing the implementation of renewable energies. She will explain more about this project too. So we can start with some questions. First of all, understand more what is BIPV. So building integrated photovoltaics are essential to reach 2030 targets. How could BIPV be defined both from an architectural point of view and from an energy efficient point of view?
So thank you, Giulia, for the kind introduction, and good morning to Build Up audience. So I'd like to start with a short overview on the history of BIPV in the past decade. So our institute at EURAC has been working in several projects in the past 10 years, focusing on BIPV. At the beginning of the past decade, a lot of research focus in particular was on technology development, such as new PV modules, new integration substructures, new components, and new systems. Another aspect that was very much brought into attention was aesthetics, because it was clear that the public acceptance of BIPV was a key factor to succeed in market penetration of this technology. So, of course, if people have a negative perception of this technology and they think that PV modules are ugly, they wouldn't like to see them placed on their buildings, on the facade, on the roofs, and in their cities. So in those years, several projects were addressing this challenge. For example, we were involved in an FP7 project named Solar Design that was coordinated by Technology University of Vienna, and with several European partners, including an Austrian PV module manufacturer, Unplugged, to develop new technologies, in particular flexible photovoltaic modules to address architects' needs. Another project was the International Energy Agency Task 41 on solar energy and architecture, developing dissemination of best practice to show how photovoltaic can be integrated with the high architectural value in the built environment. So it was made clear that architects are very important stakeholders of the BIPV value chain, who must be involved in order to succeed in boosting penetration of photovoltaics in buildings. So in these projects, the focus was very much on architectural integration level, but in most recent years, another aspect of integration arose, that is the energy integration, meaning the ability of photovoltaic to be integrated not only into the envelope itself of the building, but also to be efficiently integrated in the overall energy system of the building. So in particular, that means the ability of photovoltaic to interact with the building loads to maximize self-consumption and producing energy in the time when you actually need it. And also on the other side, to efficiently use the energy that is produced on site within one or more buildings. So the concept is maximizing the energy use on site and minimizing the energy fed into the grid. So this is basically what I mean by energy integration. So what we can conclude after this brief overview is that when we talk about integration of photovoltaic, it is essential to consider three aspects of integration. So technology integration, aesthetic integration, and energy integration. And all these aspects are really important to succeed in the BIPV design.
Yes, it was a very clear overview. Can you now go into a little bit more depth into the projects you are involved in? So the EU-funded projects and the task with the International Energy Agency, International Energy Agency. So can you share with the build-up audience the results that you obtain from these projects and also an overview of all of them in which you are involved and your research group are involved as well?
Yeah. So thank you. So I like to start with a project that EURAC is coordinating that we mentioned before already, that is an Horizon 2020 project named Energy Matching. And that it's also connected to what I said before, since it is very much focused on energy integration concept, the energy integration concept. In this project, we are exploring both technology, aesthetics, and a lot of energy integration aspects with a consortium of 17 European partners, including photovoltaic and construction companies, research institutes and universities, and also social housing entities. So regarding technologies and aesthetics integration issue, in the project we are developing new technologies in particular for the residential building energy retrofit, and in particular the technologies we are developing include, for example, a new photovoltaic integration substructure that is a click and go system developed by Tulips, which is a company from Netherlands. Then we are developing different kind of aesthetically appealing photovoltaic modules with the Spanish partners Onyx and Tecnalia. Then we are developing a solar window block in collaboration with Italian companies Eurofinestra and Pellini, where a photovoltaic module is integrated in the window block to feed a multifunctional system, including ventilation and shading. So basically that regards the technology and aesthetics. In addition, what we are working a lot on this project, since we believe it is the future for BIPV research, is on energy integration of photovoltaic within the building system, but also within a district. So we are studying on one side how to maximize energy harvesting through the building scheme, but also on the other side, how to maximize the efficiency in producing and using on site as much as possible the collected renewable energy. This is done within one building or sharing the energy among a few buildings in a district. So our aim is to design a BIPV system from the beginning of the design phase to maximize its integration with the overall energy system, including heat pumps, electrical and thermal storage, and all electrical appliances. And the end optimization of the BIPV design can be achieved through the use of a tool that we are developing within EURAC. We are also working in close relationship with the Swedish partners on this energy integration aspect with the Larna University and with technology providers NIBE, that is a heat pump producer, and Ferroam, that is an inverter producer, to develop a technology named Energy Hub that connects a local DC nanogrid, the BIPV system, with the energy storage and loads of one or more buildings, and optimizing the energy used within the nanogrid by improving the self-consumption. So basically, we are matching the BIPV production with the building's consumption. And that's about the energy matching project. You were also asking about other projects we were involved in. So I list a few of them. One is Task 15, a project of the International Energy Agency. The objective of this project is to create an enabling framework to accelerate the penetration of BIPV products in the global market of renewables. The main international partners dealing with BIPV, not just within Europe but worldwide, are involved in this project. We are also working in another Horizon 2020 project, BIPV Booster, coordinated by Tecnalia. This project is focused on cost reduction of multifunctional BIPV system. And in particular, in this project, we are supporting the development of a software to support the cost-effective BIPV design. To conclude, I'd like to mention another project that is an Interreg Italia-Switzerland named BIPV Meets History, coordinated by EURAC and SUPSI, that is focusing on solar integration in heritage sites like historical buildings and landscapes to disseminate best practices and showing different aesthetics possibilities offered by PV modules in terms of shapes, colors, surface finishing, and also thanks to technology innovation on glass, coating, and substructure system. So I'd like also to mention that within this project, we have recently launched an award to valorize the existing BIPV works in Italy and Switzerland. So I'd like to invite all designers, architects, and engineers to have a look on the website, bipvmeetshistory.eu, to find more information on the award.
EURAC has a solar laboratory when you are currently doing some tests and you use for the projects that you just mentioned. Can you explain how the solar laboratory works and what kind of tests are you performing in it?
Yeah, so EURAC has both indoor and outdoor laboratories dedicated on tests on photovoltaics, such as specific tests on electrical parameters, IEC standards, and so on, and also tests on the building energy efficiency. In addition, we have an outdoor test facility that is specifically dedicated to BIPV, that is called the PV Integration Lab, where we have the opportunity to perform tests on integration of photovoltaic systems in buildings and grids. In particular, we have a roof mock-up and a facade mock-up. On the roof mock-up, we are currently testing a BIPV system made of core BIPV modules with the so-called hidden PV technology. We have two kinds of modules. One realized with the terracotta colored glass, and the other one, same color, but realized with another technique through digital printing. We are testing the performance of this system because this kind of modules might play an important role in integration in sensible contexts such as our city centers, old town, historical buildings, and so on. So we believe that keep developing this photovoltaic module with high aesthetical value is important to address architect requirements. And as I said before, architects are the stakeholders who play an essential role in boosting BIPV market penetration. Because we might develop the most efficient photovoltaic modules, but if no one wants to install them because they don't like it, they don't like them, then we lose our challenge. So going back to our test facility, we also have a facade mock-up where we test the performance of BIPV facade system. In this facility, we did several tests on multifunctional envelope BIPV system. So where a PV module is integrated within a sub-energy system, and it is, for example, used to feed an envelope active energy system. For example, we are now testing a solar window block that is a prefabricated window integrating several functions, such as mechanical ventilation and smart shading system, where the photovoltaic module and its electronic, including battery, are integrated to feed those systems. So yeah, in our photovoltaic integration lab, we have the opportunity to test different aspects of the integration. So aesthetics, technology aspects, but also energy integration, including plug and play, standalone, and grid connected systems.
Okay, so have you developed any tools in the course of this project that you described to us to support architects and engineers in implementation of BIPV?
Yeah. So thank you, Julia, for this question. I'd like to mention in particular a EURAC website on BIPV, where we collect all tools and information that we believe are useful for architects and engineers to approach a BIPV design. So if you Google the words BIPV EURAC, you should be able to find the website. There you can find a platform collecting BIPV case studies. So if you like an example, you can download a PDF where you can find a lot of information on products used for that BIPV system, such as photovoltaic modules, energy systems, pictures, and drawing on technology details and so on. There is also a section on products that we are still updating, where you can find existing products on the market, including photovoltaic modules, mounting system, and energy systems. Then we have a section describing a software tool that we are developing to support early stage of BIPV design. At the moment, this is a tool that we are using internally to support architects and designers, but it will be available to the public in the future in around 1 year time, thanks to the Horizon 2020 project Energy Matching. So within this project, in fact, we are developing a user-friendly interface that will allow all public to access an online platform and perform simulations to support their BIPV design. So for example, you can insert data on your building or more buildings, then some techno-economic inputs, and as a result, you get the optimal BIPV system designed for that building, both the optimal sizing and position of the system. So meaning how many kilowatt peak you should install and in which part of the envelope. The tool is based on some algorithms that can optimize several parameters, such as energy matching, so the matching between electricity production and consumption, but also economic aspects, such as payback time, net present value, and so on. This is a tool that is meant to be very useful to support architects, engineers, and designers in the early design phase of a project. Finally, we have published a book entitled Building Integrated Photovoltaic in Trentino Alto Adige that is available in English, Italian, and also German version, where you can find some best practices and material on BIPV in our region. So to conclude, I would like to invite you to have a look at our website bipv.eurac.edu to have more information on the tool and on our platform with BIPV case studies and products, because there you can find interesting example and some support to approach BIPV design.
So finally, I got a question looking at the future. How do you see the implementation of BIPV in the next few years? How do you think it will impact the energy performance in buildings?
Mm-hmm. So the implementation of BIPV will regard the three aspects of integration that I mentioned before: technology integration, aesthetic integration, and energy integration. So all these aspects are and will be important to succeed in BIPV implementation. But what is becoming more and more important, I think, will be the integration regarding energy integration. So that will be the main focus. So while in the past years we were used to consider the energy production as something that was relegated somewhere far from our view in a centralized power plant, now we move toward a decentralized energy production where buildings are not conceived anymore as energy consumers, but also as potential producers that are able to harvest solar energy through their skin and then their envelope. So they are becoming the so-called energy prosumers. This is opening new challenges related to the energy sharing and how to optimize the local use of renewable energies within one multi-residential building, for example, and also among several buildings. So European policy is pushing toward the direction of energy sharing, energy communities, but there are still some technical and above all non-technical barriers that still need to be removed in order to speed up this process, such as a regulatory framework and normative aspects at country level. Anyway, this is becoming reality in overall Europe, and for sure BIPV, as the main technologies able to produce electricity from renewable energy within a building, is playing and will play a crucial role towards these energy communities.
Thank you very much for your time and for sharing with us these very innovative technologies and projects that you and EURAC and your project partners are involved in. And I want to say, keep safe in this time of uncertainty. And thank you to our Build Up audience for listening to this interview.
Thank you very much, Julia.
Thank you.